Good afternoon. My name is Karol Palomino, and together with Valeria Arias and Professor Francisco Tarazona, we developed this work titled Modeling and Simulation of Batch Distillation in a Copper Still, Economic Assessment for Pisco Production. Pisco is a traditional Peruvian grape spirit whose artisanal production still relies largely on empirical methods. As a result, product quality often varies, since head and tail cuts are defined by sensory judgment rather than quantitative criteria. Our aim was to develop a mathematical model that helps describe and improve this process, making distillation more consistent, efficient, and profitable.
According to the Pisco designation of origin regulations, the distillate must contain 38 to 48% alcohol by volume and comply with limits for methanol, acetaldehyde, and other volatile congeners. In this context, methanol and acetaldehyde were chosen due to their toxicological relevance and strong influence on product conformity. However, producers often make overly conservative cuts to ensure compliance, which reduces both yield and profitability. Therefore, we developed a model to quantify how head cuts influence composition and economic performance.
We modeled two key subsystems, the boiler and the partial condenser, combining mass and energy balances, vapor-liquid equilibrium calculated with the Unifact Dortmund model revision 6, and heat transfer correlations. The simulation was implemented in MATLAB for a four-component system comprising ethanol, methanol, acetaldehyde, and water. We evaluated three mass compositions, low, intermediate, and high, and head cuts ranging from 0.3 to 3% by volume of the initial charge.
Our results show that, first, for the low composition, no head cut was needed to meet the regulations. Second, at the intermediate level, a 0.5% by volume head cut met the standards and increased the Pisco yield by 3.4% compared to the traditional 1%. And third, for the high level, even large cuts failed to comply, highlighting the importance of fermentation control. The model was qualitatively validated through punctual trend comparison with literature data, showing consistent behavior for ethanol, methanol, and acetaldehyde. Additionally, the sensitivity analysis showed that heat input rate had a strong influence on process duration, while ambient temperature had negligible impact.
Finally, the economic assessment revealed that improved head cut strategy increased the net present value by 30.4%. Overall, this work offers a quantitative framework that connects traditional craftsmanship with modern process engineering, empowering small producers to make data-driven improvements that enhance quality, safety, and profitability while preserving the cultural identity of Pisco. Thank you.